we've learned about the frequencies of sound wavelength, and today we will learn about the loudness. Our learning intention today will be to learn about the loudness. Loudness of the sound. And first of all, if we will consider if we have a point source of sound, well, or anyway, but in our case we're talking about sound. And so something making sound, some small loudspeaker, but what's important, it emits sound in all directions even. So sound going evenly in all directions. And first, let's recall what is power. Definition: what is power? Well, guys, you should know that. What is power? What is power in general?
It's like what?
It's measured in watts, but what it is? Energy per second. How much energy is emitted per second, used per second. Energy over time. And measured in watts, 1 watt equal when 1 joule of energy used in 1 second. That's the power. So we have some source which has some source of sound which has certain power, producing certain number of watts of power. So certain amount of joules of energy emitted every second. Now, this sound is going in all directions. So it's distributed over the certain area. And intensity, I, intensity, it is how much power will falls on the unit of area. It's power divided by area. So power per square meter. When it spreads out, obviously as further away we are from source of the sound, it's covering more and more area, so it becomes less and less intense. It makes sense. It's further away from the source, it's less intense. Now, if it's moving evenly in all directions, what shape the front of the sound wave will make? If it's moving evenly in all directions.
Circle.
Circle is two-dimensional. In 3D,
Sphere.
sphere. It will make a sphere. Who remember the formula for surface area of the sphere?
So 4 pi r squared.
4 pi r squared. Excellent. 4 pi r squared. So intensity of the sound we can find using formula power of the source divided by 4 pi r squared. So it's one of the examples of the inverse square laws. Inverse square law. There are quite a lot of physics laws which has inverse square. For example, gravitational field, gravity, there will be same kind of mathematical relationship, will be inverse square law. And electric force will be again inverse square law. So it's often that when things becomes weaker over the distance, depending not just on distance, but on the square of the distance. So let's say we have sound intensity. We have power of the sound source is, let's say, 31.4 watts. We will see why I took some strange number, not very round. Yes, because it's related to pi. It will be easier to calculate. So, and let's calculate what will be sound intensity in, let's say, 2 meters away. 2 meters away from this source. So intensity equal power 31.4 divided by 4 pi times 2 squared equal pi 3.14, so will be 10 divided by 16, which is will be 0.675. I think, can you check with your calculator?
625.
625 watts per meter squared. That will be the intensity of the sound 2 meters away of that source. What is interesting that we can use the ratio of the, and that is the unit of the measurement of the sound intensity. Watts per meter squared. Watts per meter squared. Now, if you know that sound intensity at the distance R1 from the power, so we don't know what is the power of the sound source, but you know what is the intensity at the distance, let's say 5 meters. At the distance 5 meters, you know that the sound intensity will be equal, let's say, 4 watts. Question is, what will be the sound intensity at the distance 10 meters up to? So, what we can, if you write, we have I1 equal power divided by 4 pi R1 squared. I2 equals power divided by 4 pi R2 squared. So if we divide I2 by I2 intensity 2 divided by intensity 1. We will have power will cancel out, 4 pi will cancel out, and because we will divide fraction by fraction, how we divide by fraction? Keep, change, flip. So we times by its reciprocal, we'll get R2 squared over R1 squared, or R2 over R1, sorry, R1, it flips, so R1 over R2 squared, so R1 over R2 squared. What is R1 divided by R2? How many times we increase distance? Twice. So R1 divided by y. R2 is 1/2. So intensity 2 divided by intensity 1 will be 1/2 squared, which is 1/4. So if we increase distance twice, intensity becomes less 4 times. If we will increase distance 3 times, how many times intensity becomes less? 9 times. So it will be we increase distance certain number of times, intensity decrease square of this number. If we increase distance 10 times, how many times will be intensity less? 100 times, 10 squared. Make sense? Now, human ear is sensitive to a very big range of the intensities of sound. The softest sound, of course it's all individual, some people have better hearing, some worse, but like on average the softest sound that's human ear. By the way, it depends on the frequency, and that will be next week. We'll look into how our hearing of the sound changes the frequency. That sounds of the same loudness but different frequency, we hear them. It's absolutely different. It seems to us that they are very different in loudness. Even effectively, they're actually same intensity. But our ear, the most sensitive for sounds with the frequencies like from 1 to 3 kilohertz, 1000 hertz. But that we'll look into the next week. But so the softest sound that human ear on average can hear is 10 negative 12 watts per meter squared. So this is the softest sound. When I whispering, softest sound, it's much more than that. Can you hear me when I whisper? Yeah, so it's more than that. That's the softest sound that human ear can hear. And there is different, give you some examples of the sound intensity of different sounds. For example, and that's called threshold of hearing. Threshold of hearing. Softest sound that we can hear. And for example, conversation, just normal conversations, people just talking, not shouting, just talking normally. Conversation at a distance of 1 meter, the sound intensity will be about 3 times 10 negative 6 watts per meter squared. Siren, jackhammer. Jackhammer. Jackhammer at 10 meters will produce, jackhammer at 10 will produce 1 times 10 negative 3 watts per meter squared. It's quite loud noise. If you've heard jackhammer working, you know it's quite loud. And there is threshold of pain. Sound can be painful for you. If it's very loud, it can actually become physically painful. So threshold of pain is 1 watt per meter squared. So if sound will be that loud, it will be painful for your ears. And for example, jet engine produce more sound. Jet engine produce like this 10 watts per meter squared. So as you can see, our ear can hear huge range of the sound. This sound 10 in the power of 12 times more intense than the softest sound that you can hear. So it's not very convenient to operate with those numbers because it's huge range. And to make it easier, there is another quantity introduced called sound intensity level. Sound intensity level. Sound intensity level. sound intensity level, which measured in unit that all you heard about, decibel. Have you heard the word decibel?
Yeah.
It's measured in decibel. What the prefix deci means? Who knows what prefix deci means? Tenth. Decimeter is 1/10 of meter. So decibel is 1/10 of a bell. So unit is bell. Bell, not the bell that rings, bell is the surname. The person who actually invented the telephone. That was his surname. And so it's named Bell, his own. So unit is 1 decibel. And sound intensity level in decibels, equal 10 times log. We already were a little bit familiar with the logs. We're talking about the logs when we were learning astrophysics. Log with the base 10, it's more convenient because in the scientific calculator you have the button with the log with the base 10. Log 10 of intensity divided by the threshold of hearing, which is I0, which is 10 negative 12. So, let's say calculate what will be the sound intensity level for, let's say for jackhammer. Jackhammer produce intensity of 1 times 10 negative 3 watts per meter squared. Let's substitute it into the formula. We will have L equal 10 times log with the base 10. This is 10 negative 3 divided by 10 negative 12 equal 10 times 10 negative 3 divided by 10 negative 12. If you remember the index laws, when we divide powers we subtract. Negative 3 minus negative 12 will be positive 9. So 10 log 10 of 10 in the power of 9, which will be equal, this will be, what log means? Log is a power. So log, it tells that log with the base 10 of this number tells us in which power we need to put 10 to get this number. Obviously it's 9. So we have 10 times 9 equal 90 decibel. Can you please calculate now what is the sound intensity level of the threshold of pain, which is 1 watt per meter squared? Can you please calculate what will be sound intensity level? Substituting in this formula, I0 is always 10 negative 12, threshold of hearing, and instead of I, you substitute 1. $120. It will be equal 120 decibel. So this sound intensity level will be painful for your ears. So that is how we measure sound intensity and sound intensity level. I'll just do two more examples, and then we will do just practicing on the solving problems with the loudness of the sound. First example is how we find sound intensity when we know sound intensity level. So we do opposite. Let's say we know that if you know that sound intensity level is, let's say, 30 decibel. What is the intensity of this sound? This is sound intensity level. what is intensity. So we have L equal 10 log with the base 10 of I divided by 10 negative 12. So first step, we divide both sides by 10. L is 30, divide by 10 equals 3. So we have 3 equal log 10 I divided by 10 negative 12. Then to get rid of log,
10 to the 3.
we put 10 in the power, so we have 10 in the power of 3 equal I over 10 negative 12. And I will be equal, multiply both sides by 10 negative 12 will be equal 10 in the power of 9 watts per meter. Sorry, times both sides by 10 negative 9 watts per meter squared. That will be sound intensity level. Sorry, sound intensity. So if we know sound intensity level, we can walk backwards and find sound intensity. What is the actual sound intensity of that sound? So, another example, what will be the change in intensity level when sound intensity down? If we have I2 equal to I1, and we want to find change in the sound intensity level, so what will be L2 minus L1? Let's substitute it into the formula. We will have 10 log with the base 10. We have I2 over 10 negative 12 minus 10 log with the base 10 of I1 over 10 negative 12 equal. You can take 10 as a common factor, and with the logs, there is a rule when the difference of the logs, when we have log 10 of A minus log 10 of B, that's equal log with the base 10 of A divided by B. So we will have 10 log with the base 10, and we have this divided by this. 10 negative 12 cancels out, and we'll have I2 over I1. And what is I2 divided by I1? From here, what is I2 divided by I1? If I2 equals 2 times I1, then I2 divided by I1 is 2. So equal 10 log 10 2. Use your calculator, please tell me what is that log 2 with the base 10.
3.01.
It's 10 times that, right? Or just log 2 with the base 10. Andrew, what you calculated? You calculated the whole thing 10 times.
Yes.
Yes.
3.01.
Yeah. So approximately it is 3 decibels. So make a note. When intensity increased twice, sound intensity level changed by 3 decibels. You can use it as a shortcut. Make a note that when some intensity of the sound increased twice, it's plus 3 decibels. The sound intensity level increased by 3 decibels. Okay, that's all theory for today.
I think my calculator is broken.